Hey, my name is Talia. I'm a high school senior and I love teaching others about chemistry and math. This YouTube channel is an extra resource for anyone who may be needing some help in their chemistry classes. This week I'm going to be wrapping up my unit on solutions and talking about solution stoichiometry. So feel free to join me if you need some extra help. Without further ado, let's get started. Okay, so the way this video is going to be structured is I'm just going to go over what's new in solution stoichiometry, and then we are going to do one big mega problem with a ton of concepts that we've already learned in stoichiometry and bringing in some new concepts from solution stoichiometry. So solution stoichiometry involves concentration and volume, in addition to other components we've already talked about with stoichiometry. So let's do a practice problem. So now, based on what you know, stoichiometry, if you've been following with my videos, can involve mass, concentration, volume, and pressure. So our example problem is silver nitrate is reacted with aluminum chloride. We have part A, write a balanced chemical equation for this reaction. Part B, if 300 milliliters of 0.400 molarity silver nitrate is reacted with 100 milliliters of 0.200 molarity aluminum chloride solution, which reactant is limiting and which is excess? What is the mass of each of the products? If the percent yield for the reaction is 70%, what mass would actually be obtained for each of the products? And write a formula equation, complete ionic equation, and net ionic equation for the reaction, and determine what the spectator ions are for the reaction. So for part A, we want to write a balanced chemical equation for the reaction. So we have silver nitrate, which is going to be AgNO3, plus aluminum chloride, which will be AlCl3. And this is a double replacement, so the metals and nonmetals will switch places. So we are going to have AlNO3 plus AgCl. And to balance, I'm going to put a 3 in front of the AgNO3 and a 3 in front of AgCl. So now we have 3 silvers, 3 nitrates, 1 aluminum, and 3 chlorines. Perfect, part A is already done. So now we have if 300 milliliters of 0.400 molarity silver nitrate reacted with 100 milliliters of 0.200 molarity aluminum chloride solution, which reactant is limiting and which is excess. So normally, previously, when we've had limiting and excess problems, we have the mass of both of the reactants and we have to convert them to moles and then divide by coefficients and figure out which reactant is limiting and excess. In this situation, we have volume and we have concentration. And we can use those numbers and units to get to numbers of moles because we know the equation C equals N over V, which can be written to N equals C times V. So kind of on the side, I am going to first convert my volumes. Okay, so now we have the volumes of both of our solutions. I am now going to multiply that by concentration in order to get the moles of both of our solutions. So we have 0.300 liters. So now that we have the volume of both of our solutions, I'm going to multiply that by concentration to get the moles for each of our solutions. So 0.300 liters times 0.400 molarity, that is going to equal 0.120 mole AgNO3. And then for AlCO3, we have 0.100 liter times 0.200 molarity, which is going to get 0.0200 moles AlCl3. Now we're not done yet. We want to divide by coefficients. So I'm going to do this down here. 0.120 moles AgNO3, and our coefficient is 3. So we want to divide it by 3, is 0.0400 moles, and 0.02 moles divided by 1, because it's 1 mole of AlCl3 in the reaction, is 0.0200 moles. So our limiting reactant is AlCl3, and our excess reactant is AgNO3. So now we know what we want to use in future calculations. I am now going to make my table like I explained in the very first stoichiometry video that we did. I'm going to have moles on the top, and I am going to also put mass. And this time we also have volume, we also have concentration, and we can never forget molar mass. All right, so let's move on to part C. What is the mass of each of the products? So let's put in the amount of moles we have. Remember, we are using the amount not divided by the coefficient. So we are going to put in our limiting amount of AlCl3, which is 0.0200, and AgNO3 is 0.120. So now for part C, we want to calculate the mass of each of the products. So I'm not going to do mole to mole and then mole to mass. I'm just going to go from moles of AlCl3 straight to the mass of each reactant. I'm also going to put a little x here because I like to x the excess. So if I have 0.0200 moles AlCl3, I'm first going to do AlNO3. There's 1 mole of AlNO3 per 1 mole of AlCl3. And then this is something I forgot to do. We should calculate the molar mass of both of the products. So for AlNO3, we have 26.98 plus 3 times 14.01 plus 9 times 16, which would be 213.01 grams per mole. For AgCl, we have 107.9 plus 35.45, which is going to equal 143.35 grams per mole. Okay, so now we can successfully convert to mass. Back to my conversion. So I am now going to put 213.01 grams per 1 mole of AlNO3, and then just like regular stoichiometry, these units are going to cancel out. And I'm going to multiply 0.02 by 213.01, and I'm going to get 4.26 grams of AlNO3. Now let's do AgCl. So we're going to start again with 0.200 mole AlCl3. There are 3 moles of AgCl per 1 mole of AlCl3. And then we're going to multiply by molar mass. So we have 143.35 grams per 1 mole AgCl. As usual, these units will cancel out. And we are going to multiply 0.02, make that 2 a little bit more legible. We are going to multiply 0.02 by 3 by 143.35 to get 8.60 grams of AgCl. Okay, so now part D. With the percent yield of 70%, what mass would actually be obtained for each of the products? Okay, so part D is going to be over here. So as we remember, so our percent yield. So remember, percent yield is the actual over the theoretical times 100. So to get the actual mass of the products, we are going to multiply the mass by the percent. So we are going to multiply 4.26 times 0.70, because remember, We divide the percentage by 100 to get the decimal form, and I'm also going to be using my unrounded version in my calculator. So 2.98 grams of AlNO3 are going to be actually obtained. And then let's do AgCl. So we have 8.60 times 0.70. That is going to be 6.02 grams of AgCl actually produced. So these masses over here are theoretical. Now we have to write a formula equation, complete ionic equation, and net ionic equation, and determine the spectator ions. So here's part E. So first, our formula equation is our double replacement, but we have to do something new where we determine which one will be the precipitate. So we have 3AgNO3, that is going to be aqueous, plus AlCl3, also going to be aqueous, is going to yield AlNO3, which we don't know, plus 3AgCl, which we also don't know. So now we're going to use our solubility chart. So everything is soluble with nitrate. So that means aluminum is soluble with nitrate, which means that AlNO3 is not our precipitate. And just to double check, let's go to the chloride ion, and Ag+ is not soluble with the chloride ion, so AgCl is our precipitate. So that is our formula equation. So now I'm going to do my complete ionic equation where I dissociate my soluble compounds. So I'm going to have 3Ag+, which is aqueous, plus 3NO3-, which is also aqueous, plus 3, plus Al3+, plus 3Cl-, is going to yield Al3+, plus 3NO3-, and there's not enough room, I'm just going to write it here. Remember, our precipitate does not dissociate. That's a good rhyme. Precipitate does not dissociate. So I'm just going to leave it whole. And then for our net ionic equation, we want to figure out which ions are in their ion form on both sides. And that would have to be aluminum and nitrate. So for our net ionic equation, I'm going to write 3Ag+ plus 3Cl- is going to yield 3AgCl, which is our precipitate. Our spectator ions are going to be Al3+ and NO3-. All right, so that is solution stoichiometry. Not too different from what we've already learned, plus the addition of this new unit. You can get a wide range of different kinds of questions about solution stoichiometry. So that's why I added everything in this table, because they could ask you about concentration instead of mass. You could use your moles to get to pressure if you're given temperature, and volume using the ideal gas law. That is not strictly solution stoichiometry, but these problems, you never know with stoichiometry what kind they will be. So it is good to have a good understanding of all the different kinds so that you can apply them to all the different problems and see how the formulas intertwine to get you the answers you need. So that is this week's video. Next week, I'm going to be jumping into a new unit of acids and bases. And I'm going to start by talking about the difference between acids and bases and how to calculate pH, pOH, the concentration of hydrogen, and the concentration of hydroxide. So if you would like to follow along on this chem journey with me, feel free to join me back next week. As always, you can leave any questions or comments you have in the comment section below, and I will do my best to answer them. I hope you enjoyed this week's video, and good luck with learning the rest of your chemistry.